So today we are going to see the today Leetcode question, okay, and this is Expert Panda and you are watching today Leetcode question, okay. So let's go and see the today question that we have is 106 and we have to construct a binary tree from Inorder or Postorder Traversal, right? Okay, so either you will use Inorder or you can use Postorder Traversal, okay. So it is saying that statement is saying two given array we have given Inorder and Postorder, where Inorder is the Inorder traversal of a binary tree, right? And Postorder is the Postorder traversal of the same tree, and we have to construct and return the binary tree, okay. So if the traversal is given, we have to return the binary tree, okay. So let's assume we have given Inorder this one 9 3 6 9 9 3 15 27 and Postorder this one, right? So we have to construct this one, right? So Inorder is we have given, right? So how we will do that traversal, that we will see later. So we'll come back to here and we'll try to see this one, okay. So this question has been asked in you can say Google, Microsoft, and other tech company also, okay. So this question is related to array, hash table, divide and conquer, tree, binary tree. If any of the topic you don't know, please go and Google, or you will find the concept there, okay. And if you complete this question, the followed question you can do like construct binary tree from pre-order and Inorder traversal, okay. So the question is how to traverse the tree, okay. So there are two general strategy to traverse a tree, that is you can say is a DFS, right? That is depth first search, and another approach is what we have, BFS. So in the DFS strategy, we adopt the depth as a priority, right? Here in the depth as a priority, so so that one would start from root, right, and reach all the way down to the certain leaves, right, then back to the root to reach another branch. Let's suppose what I'm talking about. You can see here, right, in this example, okay. So the DFS pre-order, right, let's suppose what we have to go first, we will go to node, then left, and then right, okay. First where we'll go to node, then we'll go to the left, then we will go to the right, okay. And DFS in order, first we'll go to the left, then we'll go to the node, and then we'll go to right. And the Postorder, how we'll go, first we'll go to left, then we'll go to right, and the last we'll go to the node, okay. So this is pre-order, right, this is pre-order, this is in order, and this is Postorder, okay. And if we'll talk about the BFS, right, another approach that we use, that is our node, then we'll go to the left, then we'll go to the right, okay. Got it? So in the breadth first search, in this BFS, what we will use to, so our breadth first search, we can scan through the tree level by level, you can say. If this is a tree, let's suppose this is a tree, so first go with this root node, then go with its children, then we will go to these children, okay. So all the level, this is level 1, L1, L2, L3, right. In this way we will go level by level, right. So in the DFS, right, DFS strategy can be further be distinguished as a, you can say, pre-order, in-order, post-order, right. And depending on the relation order, you can say among the root node, we have to go to left node or right node, right. But BFS will go only with the you can say order of the height, right, from the top to bottom, right. So the number of higher level would be visit before the one with the lower levels, okay. So in this way we can see the nodes are enumerated in the order and you can visit them. So you can follow 1 2 3 4 5 and to compare different strategy. So either you will use DFS pre-order, post-order, in order, or BFS, right. So if you'll talk about this one pre-order, right, so first how we will go that, this is our one root node, right. So we'll go to the root.val, first of all we'll go to root.val, then what we will go, we'll take pre-order of this one, then we will take the pre-order of this one. So the first we will visit to 1, right? Then what we will do, we'll go to pre-order of this one, right? So then we will get COVID 2, and then again we'll take pre-order of what, this one and this one too, right? So if we'll take the pre-order of this one, so it will go to here 3, then it will go to what, 5, right? And then sorry, first then you will go to the 4 because the pre-order we have taken. So first we will go to this one, then we will go to this one, and then in the last we will go to this one, right? If the loop is working, so it will become 1 2 3 4 5 as a traversal, you can say. If we'll talk about the in order, right? In order, so first if we'll talk, we will go with what, left node. So we will check if this is root node, right? So root node, it will go to the left, so we'll take the this one for the in order. For this one we'll go to its left, so we'll reach to here. Okay, so there is no children, right? So we will take root dot left, right? So its root we will print now because left is not there, so we will print root here, root dot val, and so we'll get 1. We'll come back to here, right? And then we will do what, you can say, its left is done, so now we will do root dot val. We'll get this value, right? Then we'll go to this child, right? Then we'll get its children is not there, then we will root dot node. Similarly we'll go back to this part is done. Now we'll go to root dot val, we'll get 4. After that we'll go to right child. Means purpose is first we'll go to left children, then we'll get to node, and then we'll go to the right. So first we'll complete all the left, then we'll go to the node, and then we'll go to the right. Okay, so in this way we'll get like this one. So if we'll talk about the post order, first we'll go to the left, then we'll go to right, and then we'll go to the node. Okay, so first we'll go to the left, means first we'll pass the post order this one, then we'll go to this one, and then we'll go to this one. So first we'll print 1, then we'll print 2, and then we'll print 3. So this part is done. Now we'll go to this, and then we'll go to this. Okay, so I think you understood. Okay, now if we'll talk about the iteration, right, within the queue, because we are doing breadth first search, right? So in the BFS, first we'll go to the level wise this one, so we'll print 1, then we'll go to the level 2 and 3, then we'll go to the 4 5, right? So these are the approaches how we will traverse this one, right? So it's very important to know how we can traverse in the tree, right? So not for this problem, right, but any problem that you are going to do in the future for the you can say in the tree traversal, right? Either you will use Inorder, Postorder, Inorder, or other you will use BFS. So it will help you to understand the approach, how will you go, right? Now understand the recursion, in which we will see the recursion approach to construct this one, because we have already given pre-order, post-order, right? Or any other 2 orders if you will given, then you can create, right? If you have given the traversal things, so you can construct. So the approach we will use is recursion. So the question is saying that how to construct the tree from the 2 traversal, in order, pre-order, post-order, or anything we have given, right? So either we have given in order, or we have given pre-order or post-order, or etc, right? Like BFS. If anything we have given, either in order we have given, or other than these 2, means any of the 2 traversal we have given. So how do you construct the tree? Okay, so this question has been asked in Facebook interview, right? So and they told to do in the O of n times, right, complexity. So we'll start from not in order, usually it's pre-order or post-order one, and use the traversal picture, right, that we have seen previously, right? And because why we'll do that? Because to define the strategy to pick the nodes, you can say, right, nodes. So for example, the pre-order traversal, the first value is a root node, and then its left child, right? And then we'll go to its right child. Okay, so we like first we have gone to the in the pre-order, first we'll go to the root, then its left, then its right children, right? Like that. For post order, right? What we have gone, first we have gone to the last value is root, right? Then it's right children, and then it's left children, right? So the value picked from the pre-order post order traversal splits the in-order traversal into left and right subtree. The only information one needs from in-order if the current subtree is empty or equal to, say, we will return nothing, return null, and or if equal to, then when we will continue to construct the subtree. So what I'm talking about, see, this is the we have given, let's suppose, okay. So what we will do first, we'll try to see that implementation, right? Before doing the implementation, let's understand this is the thing we have given. This is 3 we have given as a root, and rest of the children. So this is left children and this is right children, okay. So this is the in order post order we have given, right? So post order is given here 9, 15, 7, 20 and 3, and in order is given 9, 3, 15, 20 and 7, okay. So what we will do first, from the pre-order, right, and we have given in order, okay. So if we'll talk about the left subtree, so first in the in order we'll start from what, left, then what, node, and then right. You can see, let's go back to here. You can see in the in order what we are going to, left, node, and then right. That's why I'm saying in order, this is our in order. In order we will go to left node, and then right, okay. And so first we will take 9 as a left subtree, then this is our root, and rest of these things will go where, in the right subtree, okay. So what we'll do first, we'll take what, 9 as a you can say left children, left subtree. 3 will go to a root, and then the next will go to as a right subtree, right, this one. So here first will come what, 15, right? So we'll take 15 as a left, then we'll say next is 20 will go to as a root, and 7 will go to its, you can say, right children. And that's why we have split it into left will go to the 9 will come here in order. So no left children, no right sub children we have, right? Now next, if we talk about 15, 27, left children will go, right children will go. So we'll take 15 and 20 will be our node, right? Similarly, that we have split it, right? Now it will come to what, 15 is there in the post order, right? So 15 is there. Now we have 9, 15, 7, right? In order we'll do like no left children and no right children. So you understood, right? So either you will use pre-order or post order, right? So in both cases, you can consider the example. So if we'll talk about the post one, so first we'll go to left, right, and then node, right? So in that post order you can see 9, 15, 7 and 20. So in the post order, right, 9 is what, our you can select, and other is right, and last one is our root node. So 20 is our root node. So if we construct in the both way, right, you will get this you can say array. Now if we'll talk about the algorithm, what we should do in the algorithm. So till now we have understood that we have to construct using the given things, right? So what we will do, first of all, we will use a hash map. Let's suppose we will use a hash map, okay. We will build a hash map where we'll take the map value as first we'll take one we can say value. Here we'll take the value of the node, right, and another will take the its index, right, because we have to understand its value, right? So we'll take index. So we will build a hash map, right, and then we'll take one value, another will take what, its index for its in order traversal, right? In order traversal, if we'll do an in order traversal, okay. So for in order traversal, we'll build first hash map. There will be a value and its index. Then we'll create, then first thing we will do this. Next, what we should do, we will take we should make a utility helper function, you can say, or you can say helper function. which will take as a argument left or left and right boundaries. Okay, so if there is a helper function, it should take left and right as its boundaries of the current subtree for the in-order traversal, and these boundaries are used to check if the subtree is empty or not, right? And then we'll check if it is empty, then we'll return nothing. If it's not empty, then we will traverse and we'll make pick the last element traversal as a root, like where Postorder will do, and then finally we'll return root something that we will see. Okay, so in this way we will try to implement, right? So first of all, what we'll do, we'll make a hash map. Then we will do what, we will make a helper function. We will put left and right boundaries for the current subtree in the subtree in the, you can say, in-order traversal, and these boundaries will use to check if the subtree is empty or not. So here's how it works. Like we will take, if this is left right, if this is left right, so if it 0, we'll take right also. Let's suppose it is also 0, right? Not 0, it should go to n minus 1, right? So it will left will go to 0, it will go to n minus 1, correct? And we'll check if in this function it will check if left is greater than the right, then we will return nothing, we will return null. Okay, we'll return null, and we will pick the last element as a post traversal as a root, right? And the root value for the last index in the in-order traversal left to index minus 1 belongs to the left subtree, and we'll move like that. Okay, so let's go to the coding section, right? And we'll try to implement, but there is implementation section also, in which we will see how to implement this one. Okay, let's suppose we have given this Postorder in-order traversal, right, that we have already seen. So what we will do, first of all, if we'll talk about the Postorder, right, we have given Postorder and we have given in-order. So if we'll talk about the in-order, so first thing is 3 will go to what, 3 let's see, in order will go to left node and right. Okay, left node and right. So first is left, 9 will come to what, it's you can say left subtree, 3 is its root, and rest of it will come to its you can say right subtree. Okay, now it will look like how this one. So now right subtree is this one. So in the right subtree, this will go to left, 15 will go left, 20 and 7, LNR, remember. Okay, you have to follow like this. Now we will have what, 15, 27 we have, right? Now we have Postorder. So first we have what, 9, 15 and 7, 9, 15 and 7. So left, right and node. So this is our Postorder. Left is what we have, left we have is 9, right? And this is 15, and the node, you can say, if you see the node, so node we have 7, and the in-order traversal also have 7. So both are matching here, right here, and no left no right subtree we have. Okay, similarly if you check about, if you check 9 and 15, you can also see 15 is here, Postorder, right? Or if you talk about this one 9, both are having 9 in the starting left. So tree is constructed. Okay, so now let's go to the coding section, and we'll try to so we are here at the coding section, right? So what we have given tree node, we have given in-order and Postorder traversal we have given. Okay, now we have to into implementation. So what we will do here, we will try to implement this one. Okay, and let's see how we'll implement this one. Okay, so first of all, we'll come to our what we can say, we'll create one left we have given, right we have given. Okay, so first of all, what we should do, we have built tree, right? Okay, so okay, fine. First we'll take one you can say Postorder, right? We have given Postorder, so we have to create yeah, what we'll do, first of all, you should create one class level variables. Okay, let's suppose we have given one int post index. Okay, that is called index. We'll take index. Okay, or in the sort post index, right? Let's suppose we have post index. Now we will take what? Int. We'll take that is array. It is array, and this our post order. Another will take integer as like this only, and we'll say this is our in order. Okay, like this. Now what will happen? Once we will come here, we'll say this dot. See why I'm doing this, because we should have the data directly here, right? So we'll take post order and we'll add onto the post order like this. We are setting the value here. Okay, then we have what? This dot in order, and we'll say in order. This part is done. Now we will start from the last post order element. So what we'll do, we have post, you can say index, and this is nothing but what we have our post order. This is our post order index, right? And we can directly take from here dot, will take length, and if we'll do the -1, we'll start from here. Okay, so this is we are going to start. We are starting the last, you can say, order element. We are starting from the last element, you can say, starting from the last element. Now we'll come to what we should take. Now we have to build the hash map, let's suppose. So build hash map. How we'll do that? We have to take value and its key, right? So to do that, first we'll take one ID. Suppose this is our IDs. Now for index, you can say index, and first we'll take what? Integer val, and it will come from what? This is array, right? So I will take from in order, right? Now what we should do, first we'll say this is our index, right? Index, we'll say index, we'll take a map. Okay, index will take, okay. What we should do, not here we should write actually. If you write here, so it will update its value. Better what you'll do, you write here hash map. Let's suppose we'll create one hash map here, and this map will take what? Integer, and another will take also integer, and this is our index hash map, right? Index map, you can say, equal to new hash map. This will go like this. Okay, so what we should do, we'll take one index hash map here. Okay, and here we should use put method. Okay, and in the put, while doing the put, we'll pass two things, key and value. So key is val, and its index we have to update. Index plus plus will do. Okay, so initially index value will be what? 0. Okay, so initially index value will be 0, and we have to update its value, right? Next each time. Now we'll if this is done, then we should create one helper function. So we'll return, you can say helper, or utility function, you can say. We'll create one helper function, and this function will do what? We'll start from 0 index, then we'll go to the we have in order, right? In order, and we'll pass the dot length, okay, -1, last element. Okay, so we are passing actually left and right boundaries here, right? Left and right boundaries we have, right, as parameter. Okay, so what we will do, we'll go to the helper function and we'll create this helper function. So let me go here. So as you can see, this function is returning what? Tree node, right? Here you can see. So what I will do here, I will write here this function and we'll use the same return type here. We'll use the same return type. Okay, now what we will do, we'll update its argument, right? So first what we have 0, and that is our we see left argument we have. So if this is integer, we'll say left index, right? I'll say left index, and this is our right index. This is our right index. Now what we should do, first we will check if there is no element to construct subtree, right? Means we don't have a left index. You have left index is less than your right index, then it will work. If not, means we have to say greater. If it is greater than this one, means we have to return nothing. We will return null. Return null. If left is less than right, then we will do pick up the post index element as a root, right? If not, then what we should do, we should pick you can say we'll do pick up the post index as post index element, you can say element as a root, correct? And to do that, what we have to say, we'll take int root value is we'll take a post order, not post index, it should be post order. From the post order, what we'll do, we'll pass post index and we'll get the element. Okay, this is our root element. Now we'll create one tree node, and this is nothing but our root, and we'll say new tree node, it will go to root underscore value, like this. So now our root is ready. Two things we will do. First, we will the root split in order list into left and right subtree. Okay, so to do that, what we should do here, we'll say int, we'll create one index, and we'll index underscore map we have, and we'll get our root value, root underscore value. So here what will happen actually, we have root, right? So root will splits in order list into left and right subtree. Okay, next what we have, we will do recursion, right? To do the recursion, what we should do, we will use we have post index, right? We have post index, and we'll do what, minus, because we are starting from the last index, right? Now we will build right subtree. how we'll do? Build right sub tree. To build the right subtree, we will do what? Root dot right, and this is nothing but helper function, and we do know about the helper function. We have to pass our index, right? This is our index, yeah, plus 1, and our right index. Similarly, we have to build left sub tree, and we'll say root dot left equal to helper function. It will take what? Left. We'll start from the left index and then index minus 1, right? And then we will return root. I think you have understood. Okay, so what I have did here, let me check. First of all, we'll check post order. The last element will check. Inorder post order will take, and this one. Okay, and then what we will do, we will traverse. We'll take a post index, right? We'll update our post index, and we'll check this one here. Let's go to the compile. Okay, helper function. Where is helper function? Int we have not passed. Let me run this one. There is return element, line number 33. We have returned the root, right? And 33, and this function has not returned anything. Okay, so here we are returning you can say helper function, right? It is returning, but we have created what? This for loop, right? So either we have to remove this one, and now this will work. We should not put into there. Let's submit this one. So consistency is the key. See you tomorrow. So let me summarize this one. Okay, what I'm doing here. So if you will see here, post order, right? What I'm taking, I'm taking the post index, right, and we'll update our post index value from the post order array, and we'll update its value. Now we will taking the post order and in order things. Now we will have our hash map, and what we will do, we'll update our hash map through what? Value and its index. We'll create one index and we'll update its index value 1, 2 or 3, like that. It will update each time. We'll create one helper function, right? So helper function will pass the left and right boundaries, and will construct our, you can say, helper functions to construct tree node. So what we'll do, first we'll check if the left index is greater than the right index, we'll return nothing. If not, then we will find our root value. How we'll do? So if from the post element, right? So from the post order, if you'll pass on the post order, if you'll pass the post index, means the last index, then we will get our root value. Okay, and to construct the root, we'll take root as a new root and we'll pass the value. Now what we will do, we'll get the index of the root, right? So index from the map, we will get a root value, right? That will get the index. Now what we will do, we'll do post index minus we'll do, and then what we will do, we'll update our root dot right, and from the root dot right we will build our right subtree, and from root dot left we'll use our helper function left index to index minus 1, and we'll construct our left subtree, and finally we'll return root. So if we will talk about the time complexity, right? So you can see we are visiting all the nodes, right? And so time complexity will become what? TC will become O of n, right? Because if you compute, there is a you can say master theorem where we used to implement in the mathematics, right? T of n is, if you remember in the mathematics, a of t plus what a b by n. We used to do plus there was a theta. Let's suppose there is a theta. What I'll take in place of theta, I'll take at the rate. Let's suppose this is our theta, and n to the power d we used to write. Okay, so this is our helper function, right? So if we compute the solution with the help of master theorem, this is our master theorem, right? The equation represents dividing the problem up to a sub problems, right? That is n by b, you can say. And you can say of theta of n to the power d, you can also say time. So here it divides the problem into sub problems, a equal to 2. The size of each sub problem to compute left and right subtree is a half initially. You can say b equal to 2, and all the times happens in the constant time d equal to 0. That means log b and a log b of a is greater than d. That is the difference, right? So it's dealing the case that is means of n log base b of a, that is equal to O of n time complexity. So in the shortcut, you can say we are traversing all the elements with this given orders, right? Post order, pre-order, right? And so that's why we are getting time complexity of n. On if you will talk about the space complexity, you can also say O of n is the time complexity, because we are storing this we store the entire tray here, right? So that's all for today. If you like this video and if you have any doubt, please ping in the comment box, so I will help you there. Okay, so thank you guys, thank you so much for watching this video. If you like this video and you want more videos like this, please subscribe this channel. Thank you so much.